Good morning to everyone. Myself, R.NEKIN, Assistant Professor, Department of Mechanical Engineering from PSM College of Engineering and Technology. Today, we are going to see about the 3D printing technology used in the industry. First of all, I listed the contents available in the 3D printing technology. First of all, we will see about what is 3D printing and how it works and what are all the methodologies and technologies available in 3D printing and advantages, disadvantages and applications of 3D printing and industrial growth regarding 3D printing and what are all the changes during implementation of 3D printing are listed in the upcoming slides. Next, what is 3D printing? 3D printing is a additive manufacturing technology. It is 3D printing is a additive manufacturing technology, and it makes object by using layer by layer deposition by using 3D printers, and it makes three-dimensional solid object from a digital file. Second, there are three types of manufacturing processes. First one is subtractive manufacturing. Commonly, we are using subtractive manufacturing. In lathe or drilling, we are using subtractive manufacturing. We are removing material from the existing part. It is called subtractive manufacturing. Same like that, in 3D printing, we are depending on the additive manufacturing. We are adding layer by layer and finalizing the 3D part is called 3D printing. And another one is formative process. Bending, forging all comes under the formative process. How it works? First, a virtual design of object is created using a CAD modeling software. What are all the CAD modeling softwares available in our mechanical is SolidWorks, CATIA, Creo, and that's are the few examples for 3D printing, 3D solid modeling softwares. And CAD modeling uses a 3D modeling program, or 3D scanner is used for virtual design. And that particular software slices final model into hundreds and thousands of horizontal layers, and it will send the information to 3D printer by using STL format. And finally, the 3D printer will make the final product. And the different technologies are available to manufacture a 3D printing. First of all, stereolithography apparatus, first method is. Second method is fused deposition modeling. And third one is selective laser sintering. And fourth one is direct metal laser sintering. And final one is laser engineered net shaping. These are all the methodologies and technologies available in 3D printing. First one is stereolithography is a liquid based methodology, and fused deposition modeling and selective laser sintering, direct metal laser sintering, and laser engineered net shaping are explained in the next slides. First of all, we will see about the stereolithography apparatus. Stereolithography apparatus mainly consists the components like laser source, XY scanning mirror, resin tank, and UV curable resin and cute part. The final part is called cute part, and building platform and elevators. We can see in the diagram. First of all, the laser source will strike the XY scanning mirror, and the XY scanning mirror will change the direction of laser source, and it will focus on the UV curable resin. It is available in the resin tank. UV curable resin is available in the resin tank, and the elevator and movable build platform will move in the Z direction from up to bottom direction. And if laser first step we are modeling our 3D modeling SolidWorks software or any other 3D modeling software, and we are sending it to 3D printer. During that, the 3D printer stereolithography apparatus send laser source to XY scanning mirror, and it will focus on the resin, UV curable resin, and that particular resin is heated and it forms first layer. It is mentioned in blue color, we can see in the slide, it is mentioned in blue color. And after that, the elevator system moves below 0.1 mm or 150 micron to 100 micron. It to move in Z direction, and the next layer will form by using laser laser as a heat source. It will heat the UV curable resin, and the resin, the liquid is converted into solid and forms a final product. And again the elevator will move 0.1 mm or otherwise 50 micron below in Z direction, and another layer is formed, and again the particular step is repeated and final product is made. And next, I listed the principles, same thing. I will read. The SLA process, selective laser apparatus, is based fundamentally on the following principle. Parts are built from the photocurable resin that cure when exposed to a laser beam, which scan across the surface of the resin. Next, the building is done layer by layer. I already said it will made by layer, and each layer is being scanned by the optical scanning system and controlled by the elevation mechanism, which control at completion of each layer, and final product is made. Advantages of selective laser apparatus is good user support. It is a computerized process, so it is easy for user interference, and anyone can manufacture their own product. So it is a good user support, and built volumes. We can manufacture small amount to large value depending upon our requirement. We can manufacture how many company we can manufacture from low to large volume. And third one is good accuracy. The accuracy of selective laser SLA is good accuracy and can thus be used for many application areas. And surface finish is best comparing with other 3D printing technologies. And disadvantages, some of the limitations also there. There are require support structures for extra projection. We require a support structure, and some post processing also needed to, and requires post curing application. We can apply this technology for manufacturing prototypes, for design analysis, verification, and functional testing. We can make prototype, and we can test practically, and we can produce low volume production tooling, and we can manufacture tools and fixtures and tool design and production tooling also. Next method is fused deposition modeling. It is a solid based 3D printing technology. First, the components of fused deposition modeling is filament spool and extruder, heater block and heater nozzle, and print head and print bed. First of all, we can see in the diagram, the filament spool is readily available in the market, and it consists of extruder, uses torque and pitch system to feed and retract the filament precise amount, and it contains heater block to melt the filament to a usable temperature, and finally the extruded part will be printed on the print bed. Okay. Next, advantages of fused deposition modeling is fabrication of functional parts. We can manufacture functional parts, like we can manufacture complex shapes, and we can make tie gears and tie jewelries, or we can make ornamentals. And in fused deposition modeling, the wastage is very minimum, and we are only adding layer by layer. We are not removing material, so wastage is minimum. Ease of support removal also very easy, and ease of material change. The material spool is available in different material, and we can change material based upon our requirement. We can change our material. And FDM, in here also FDM, lot of some of the disadvantages will be there. First one is restricted accuracy due to shape of the material used. The filament form, the filament is in standard form, standard diameter, and due to that restricted accuracy due to the shape of the material used. It is a slow process. It will take, for a small object also it will take more than an hour, and for large product it will take a large 10 to 12 hours also it will take. Unpredictable shrinkage also cost in FDM process. Also another one disadvantage is we can manufacture some limited sizes only. We cannot manufacture large sizes like room size is a 3D printing object. We cannot manufacture large size 3D printing object, 3D object. And next is 3D printing application. Same like that, it also used for model for conceptualizing and presentation. We can make 3D printing by using FDM, and we can present 3D. For better understanding, we can make 3D object and we can present in front of observer. And second point is prototypes for design analysis and functional testing. We can manufacture prototypes, and it can withstand can withstand the same like original object. It can withstand. And third one is patterns and master for tooling. Model can be used as pattern for making pattern in investment casting. We can use FDM, and sand casting and molding also we can use. Next one is selective laser sintering. Selective laser sintering is based on powder-based methodology. It use powder to 3D object. It is converting, and for the main components of selective laser sintering is laser. Laser is the source, and the second one is scanning system, and third one is building chamber, and fourth one is powder delivery system, and fifth one is powder material, and sixth one is roller or leveler. First, we can see in the diagram, the laser is projected on the scanning system, and the scanning system moving XY is a direction, and it will focus on the powder bed. And powder delivery system has one piston, and it will move to up and down direction, and it will supply powder to the roller, and the roller will supply the powder to fabrication bed, and fabrication bed will move up and down by piston. And in this process the sintering will happen. The laser beam is strike over the powder. The powder is sintered and forms one layer, and it is surrounded by unsintered material in previous layer, and it is used as a supporting layer, supporting structure or supporting layer. And one layer is finished. After that, the fabrication piston move in lower direction, down direction, and next layer is formed based upon the 3D object available in the CAD software. Depending on the CAD model, it will make the final product, and again next layer will form, and again layer by layer is formed, and depending upon that, fabrication piston will move from up to down, and final product is made here in the object being fabricated. It is mentioned in the picture. Here the final object is made. And in selective laser sintering advantages, the part stability is good comparing with other technologies. Parts are created within a precise control environment. There is no other disturbances, air disturbances or temperature disturbances or humidity disturbances, no disturbances. Yes. So good part stability and wide range of processing materials. We can use wide range of material including nylon, polycarbonates, metals and ceramics also we can use in selective laser sintering. And no support structure is required. Main point is no support structure is required. The system does not require CAD developed support structure because this saves the time required for support structure building and removal. Fourth one is little post processing required. Post processing is very minimum. Finishing of the part is reasonably fine and requires only minimal post processing, and no post curing is required in selective laser sintering methodology. The disadvantages of selective laser sintering is large physical size of the unit. The unit size selective laser sintering requires large physical unit, physical size. So the separate room is needed for installing selective laser sintering machine. We cannot move from one place to one place easily. It, it consumes higher power comparing with other technologies. Is poor surface finish also there. These are all the disadvantages of selective laser sintering. And application for making concept models like physical representation of design used to review design ideas, form and style, we can use selective laser sintering. And the second one is functional models, working prototypes also we can make using selective laser sintering. Parts that can withstand limited functional testing and fit and operate with the and assembly. We can manufacture metal tools, direct rapid prototype tools, molds for small or short production. So for short production runs, we can make tools also. Next one is direct metal laser sintering. It is also based on the powder based technology. Here we can see the direct metal laser sintering technology. Same like that, it consists of powder overflow component and powder feed component, and in the middle we can see build platform. So in some direct metal laser sintering, in double both sides, both the left and right side, they will provide powder feed component for faster making. Okay, in the here also laser source is focused to the XY scanning mirror, and it also consists of XY scanning mirror and laser beam, powder overflow piston and powder feed piston, and building platform and leveling roller also available. First working principle, the laser is focused on the XY scanning mirror, and that particular laser beam will fall on the build platform, build compartment or build platform, and first layer is formed based upon the 3D model and in the designing software. First layer is formed, and after that the powder feed component will move in the upward direction. The powder feed piston will push the powder feed component that particular area to upward direction, and the leveling roller will supply the powder to build compartment, and it will move from right, leveling roller will move from right to left direction, and the overflow powder will be segregated in the powder overflow compartment, and the powder overflow piston will move in the below direction, and next layer is one layer is formed, first layer is formed. After that the uh, powder is converted into solid, and the piston build piston moves up down direction, moves in the down direction, and next same like that the powder feed piston moves upward direction, and the leveling roller will supply the powder feed to the build platform, and the overflow powder will be moved to the overflow compartment, and powder overflow piston will move to the below direction, and Same like that, the same process is repeated and final 3D object is made by layer by layer deposition and final object is made. And same like that, in the right side we mentioned the powder delivery system, and left side is powder overflow piston is available. First, the roller is moved, supply the powder feed from left to right, and from that above the laser source is supplied, and first the sintering process will take, and first layer is formed, second layer is formed, and finally layer by layer is formed, and final product is made. Direct metal laser sintering advantages. Direct metal printing. DMLS can produce metal parts directly. DMLS can be used with metal alloys or pure metal without affecting the properties of the metal. Even mixture of powders can be successfully printed. Aluminum, nylon also we can print using direct metal laser sintering. We can use variety of materials such as metals, metal alloy powders are also available, including steel, stainless steel powders, aluminum, titanium, nickel alloys, cobalt, chromium, and precise metals we can use in DMLS printer. But we can only use metals only in direct metal laser sintering in the powder form. Okay. Third one is strong functional parts. The finished part is very very strong and we can use directly in any equipment. It is the strength is compared with the part casting part. The property of finished part are comparable to the part cast in the same material. Strong functional metal parts are produced by the DMLS process. Recyclable, fourth point is recyclable material. We can recycle the metal powder that are not sintered or melted is reusable. Side you can see in the previous slide, the overflow material powders are collected and we can use in for future. The limitations of DMLS. The price of the DMLS printer is very very high, and the porous parts, finished DMLS parts are porous and related to a melting metal part. Porosity can be controlled but not eliminated in this process during post processing. Small parts, most DMLS printer have relative small building volumes, same like that in FDM. In here also DMLS printer also we can manufacture small parts only. We cannot manufacture room size component. Small component also it will cost is very very high in DMLS metal laser sintering process. Application. DMLS is used in medicine areas, dentistry, and aerospace industries. First, in medicine industries, custom prosthetics can be modeled and printed in materials like titanium alloys to replace portion of bones lost to accidents or disease. We can replace our bones by using titanium alloys or other materials. We can use direct metal laser sintering technology and we can manufacture bones, metal bones. And in dentistry also we can use prosthetics, bridges, crowns and partial dentures are easily modeled specifically for the patient, then printed in high strength like cobalt chromium. We can manufacture our crowns depending on the patient size. Our teeth also we can manufacture using 3D printing technology. We can measure and we can model using 3D printer and we can print using 3D printer. Final one is aerospace industry. DMLS is key part of reducing part count and creating complex geometries and weight reduction while maintaining or increasing part strength and durability. In aerospace industry, it is a key part for reducing part count and creating complex geometries. We can manufacture complex parts or obsolete parts. Previously supplied parts from the supplier is obsolete, and we can manufacture that particular part number and part by using 3D printer technology. After that, final one is laser engineered net shaping technology. The the principle of the laser process, the lens process is based on the following two principles. First one is a high-powered ND-arc laser focused on the metal substrate, create a molten puddle on the substrate surface. Powder is then injected into the molten puddle to increase material volume. First point. And second principle is a printing motion system moves a platform horizontally and laterally as the laser beam traces the cross section of the part being produced. After formation of a layer of the part, the machine powder delivery nozzle moves upward prior to building next layer. Next, this is the diagram of laser engineered net shaping lens technology. The first one is machine table, and above that the substrate will be there, and above that substrate the fabricated part will be created, and in upward direction, first laser beam will be there, this beam will be there, NDR laser beam, and powder feed delivery also available in the same area, and shielding gas also provided. First, the metal powder is supplied from powder feed technology, and it will form over the substrate, and the laser beam NDR laser is focused on the metal powder, and it will create a molten pool, and it will form a one layer, and the same thing is repeated in first layer and second layer, third layer, and number of layers are thousands of layers are created and formed using the laser engineered net shaping. By using laser engineered net shaping, we can repair the existing part also. For example, some tape or water tape or some other tapes are repaired, we can add that particular damaged part only we can repair by using laser engineered shaping. We can add particular area only, we can manufacture particular area only, we can repair. And next, the lens advantages. The lens process is capable of producing fully dense metal parts, and complex parts also we can manufacture, reducing post processing time. And disadvantages: limited materials only available, and a large physical unit size, same like that, it also very larger in size. It consumes high power consumption. Application: fabricate titanium components for biological implants like bones, build mold and die, and producing titanium parts in racing industry. Industrial growth of 3D printer: it will change the nature of commerce, because we can manufacture in the industry, we can own manufacturer will make their own product, we cannot depend for other companies for sub assemblies. We can manufacture whole assembly, we cannot wait for other sub assemblies, we can make our own assembly. Second point is 3D printing will change the manufacturing value with effect on energy use, waste reduction, customization, product availability, medicine, art, construction, and sciences. Challenges for implementing the technologies: cost is very high, and inability to easily print in multiple material on the same machine. We cannot print the same, inability to easily print multiple material on the same machine. We cannot make multiple material in the same machine. A decent standard for model designs. Speed is very slow. It will take 10 to 12 hours. Finally, thank you.